Hello and welcome to yet another exhilarating video in geometry, and this is a video over section 5 in unit 6, which is a section about solving for an angle measure of a right triangle. So what we'll be able to do is we will be able to solve for unknown angles in right triangles using what we call inverse trigonometric functions. Okay, so it's pretty cool. So here's what we've got now. In like a right triangle, let's say you have a 60 degree or a triangle that has a 60-degree angle. Okay. And let's say that this is 60 degrees. Then this would be 1 and this would be 2. Okay. So if you said cosine of 60 degrees, you would take the opposite side, which is 1, divided by the hypotenuse, which is 2, and it gives you that. Okay. Now, an inverse trigonometric function means that you switch your inputs and outputs, okay? So you switch these numbers, okay? You switch. And then you put a little -1 up top, okay? So when you write this statement, cosine of 60 is equal to 1/2, okay, the inverse that you would write would be cosine to the -1 power of 1/2 is equal to 60 degrees, okay? And you'll be able to see that, you on your calculator, you'll see cosine, sine, and tangent, but then you'll also see the ones with the -1s ahead of it, okay? So what I'm going to do down here, I'm going to do a practice problem, and it's going to be a solve for an unknown angle measure in a right triangle. Okay, so we're going to find the measure of angle F down here to the nearest degree. Okay, so that's what we'll round to. And what I'll do is, given what I have here, all right, I'm here to try to find angle F. Okay, and I'm going to call that, instead of F, I'm going to call that X degrees. Okay, so looking at this, okay. Thinking about what my hypotenuse is, okay, I'm going to label that. This is my hypotenuse. Okay, given angle F, this is my opposite side, and then this length here would be my adjacent side. Now you're given, okay, the opposite side and the hypotenuse. Now if we think of SOHCAHTOA, then you have to think about, okay, what are we given? We're given opposite and hypotenuse. So because we're given opposite and hypotenuse, we have to use our sine function. Now what I do is I set it up like I would just a regular sine function. And I would say sine of x degrees is equal to the opposite side, which is 8, divided by the hypotenuse, which is 15. Okay, now remember how we did this, how you would have an actual angle measure, and then on the other one you would have, like one of these would be a variable, because your angle is the variable. Okay, this is your angle. Okay, this is your angle, this is your ratio. Okay, right here, this is your ratio. Okay, this is your fraction. Okay, when we're trying to solve for our angle, okay, the only way to get this out is to use our inverse. Okay, so if I rewrite it like this and say sine inverse of 8/15 is going to be equal to x degrees. Okay, so really what's happened here is these things have been switched. Okay, and they've been switched down here. All right, and that's the idea. So you switch those, you write out your regular trig function, and then you switch them and take the inverse. So this is the part that I'm going to plug into my calculator. Okay, and so let me go to Desmos real quick and plug that in and evaluate it and see what we get. Okay, now when I plug that into Desmos, the thing that's going to be a little bit different for you is that instead of sine inverse, when it says sine to the -1 power, they use arc sine on Desmos, okay, and that means the same thing. Okay, so sine inverse and arc sine, those mean the same thing. Okay, make sure that you are in degree mode when you're doing this because you're dealing with degrees, and this is my answer. Okay, so I would say that x is equal to approximately 32 degrees. okay? And that's what this angle measure is here, all right? So, whenever you're finding, an answer to a problem like this, where you've got, say, something like, something like this where you've got solving for an angle measure in a right triangle, your number should be somewhere between 0 and 90, okay? It should make some sense to you, okay? So that's what we've got. All right. All right. So on this next one, this is a real world problem. And for these real world problems, typically these have already happened, so these are actually true stories, so just so you know. All right, so anyway, okay, it says an airplane is heading 156 miles north and 234 miles east of its current location to arrive at its final destination represented by point D. Okay, so, think of this as like a grid. This is, the direction going north. Okay, this is the direction going east. And so, instead of doing, this right triangle maneuver, okay, if you're flying somewhere, you're just going to head straight there, okay? Where we're going, we don't need roads. Anyway, so what we want to do is how many degrees east of north, so how many degrees this way, theta, should the plane fly? And round to the nearest degree. So what happens is when you're in an airplane, this is an actual thing where you have to pick the angle from north or whatever cardinal direction you're going to pinpoint where you need to go, okay, in an airplane. So let's go ahead and take a look at this and solve for that. So looking at this angle, and this is the Greek symbol theta, okay. Given the angle theta, let's label the rest of our triangle. Now this is my opposite side here, this is my hypotenuse, and this is my adjacent side. Okay, so because I'm dealing with the opposite side and adjacent side, when I think of SOHCAHTOA, okay, because I'm only given opposite and adjacent, I'm going to use the tangent function. So I would write this out, okay, I would say tangent of theta, okay, of that angle theta, is equal to the opposite side, which is 234 divided by 156, okay? Now, this is my regular trig function, okay? This part here is my angle, this part here is my ratio. What I'm going to do to solve for theta, I need to do tangent inverse. So I'm going to rewrite this as tangent inverse of 234 divided by 156, and that's equal to theta, okay? And when you would write that out, okay, in your calculator, the same thing that you could write would be arctan, okay? That means the same thing. So arctan of 234 over 156 is equal to theta. All right, so let me put that into my calculator real quick and we'll evaluate it and see what we get. Okay, so when I plug this in, okay, and I'm just typing in arctan of 234 divided by 156, I get a value of 56.3. So theta, rounded to the nearest degree, okay, rounded to the nearest degree, make sure we always read how many units you need to round to. Theta is equal to 56 degrees. And that's our answer, and that's what we're solving for. And that makes sense. 56 is between 0 and 90 because either of these angles have to be between 0 and 90 degrees, okay? Okay, let's go to the next page. Okay, and the next one, we need to talk about the concept of angles of elevation and depression. And these are angles, and this isn't, talking about depressed angles, angles that are sad. Angle of elevation means that you go up. Okay, the angles go up, okay, or the angles go down. Okay, that's kind of the way to think about it. So an angle of elevation is formed between the horizontal and the ascending line. Okay, so here's your horizontal, okay, and you have to think about the angle going up. Okay, the angle of depression is formed between the horizontal and the descending line. So here's your horizontal line, and then here is the angle going down. Okay. So then it says, what is the angle of elevation from point F to point G, okay? So what you'd want to do is you need to create this horizontal line here, okay, and then create this angle measure between the horizontal and this line G, okay, and this would be your angle of elevation, okay. If we wanted to talk about the angle of depression from, say, point G to point F, okay, make your horizontal, okay, and then think about the horizontal down to that line created here, okay, and this would be your angle of depression, okay. So we use this a lot when we're talking about, some of these different types of problems. So let's go ahead and talk about this one where it says determine the angles of elevation. And so what we know, okay, a tree that is 14 feet tall casts a shadow that is 30 feet long. Find the angle of elevation from the tip of the shadow to the top of the tree, rounded the nearest degree. So we know that this tree right here is 14 feet tall. So I'm going to come over here and label this as 14 feet. Okay, and we want to find the angle of elevation. Okay, so we need an angle that goes up from the horizontal. This line right here is your horizontal. Okay, so find the angle of elevation from the tip of the shadow, right here, to the top of the tree. Okay, and that angle of elevation would be right here. I'm going to call that X, okay, for that angle of elevation. All right, now given angle X, okay, this is my opposite side, this is my adjacent side, this is my hypotenuse. Okay, thinking of the concept of SOHCAHTOA. All right, I'm given the opposite side and the adjacent side, so I have to use my tangent function, okay? So if I come in here, all right, I'm going to write that function out as tangent of x degrees is equal to my opposite side, which is 14 divided by 30, okay? Now, to find my angle measure, I have to switch my input and out, my angle and my ratio, okay? And I'm going to write tangent inverse of 14/30 is equal to x, okay? And another way to write that is using the concept of arctan. So arctangent of 14/30 is equal to x, okay, depending on what you've got as far as on your calculator. So let me go and plug this in the calculator and see what we get. Okay, and so what you can see once I plug that in, arctan of 14/30 is equal to 25.01. So what we can conclude here is that x is equal to 25 degrees. And that's it, okay? And that's what we've got. All right, let's take a look at the next one. It says relating angles of elevation and depression. Okay, and one thing I want to point out here is that the angle of depression from point A to point B is congruent to the angle of elevation from point B to point A, okay? And so the way I kind of want to talk about that is this, is let's draw a horizontal line here, okay? What I know is that this angle here is congruent to this angle here. Okay, and the reason why, we have to kind of go back to that concept of two parallel lines, okay, horizontal lines are parallel, cut by a transversal from A to B, okay? And these angles would be alternate interior angles, and that's why they're congruent. So you can always kind of figure those out knowing that property. There's some questions we can answer based off of that. Okay. On this one, we want to determine the angle of depression. And so let's go ahead and read this. And it says that Isaac stands 485 feet from the base of the Statue of Liberty. So this distance here from Isaac, here's Isaac, here's the Statue of Liberty. I didn't want you guys to get confused on which was which. But the distance here from the base of Statue of Liberty is 485 feet. So I'm going to come in here and let me just write that this is 485 feet, Okay, and whoop. And it says, if the Statue of Liberty, the whole thing, is 305 feet tall, what is the measure of the angle of depression from the top of the statue's torch to Isaac's line of sight? So what I'm looking for is this. All right, and hold on, give me 1 second here. Let me do one thing at a time. Okay, let me draw this horizontal line. We're trying to find this angle here, which we'll call x. Now, what we also know is that that angle is the same thing as this angle here, x. Okay, so, your angle of elevation here is the same thing as your angle of depression, okay? Now, the other thing is that the Statue of Liberty the total thing is 305 feet tall. So this distance from the top of the torch down to the bottom of the ground is 305 feet tall. Now, here's where this problem gets a little tricky, is because this triangle right here, okay, dealing with Isaac's line of sight, has a difference of 5.5 feet. So in order to find this length of the triangle, I have to subtract 5.5 feet from 305. So if I do that, then the height of this is going to be 299.5 feet. Okay, and all I did was subtract 5.5 feet from 305. Okay, so then what I want to do is to find x. Okay, we need to use our trig functions, but let's label our sides. So given this triangle here, to find out what x is, all right, let's label our triangle. Looking at that angle here, my hypotenuse is here. Okay, this is my opposite side, and this is my adjacent side. Okay, now let's write out what we know about our trig functions. We know so, ka, toa. All right, and so, ka, toa, just based on what we're given the opposite side and the adjacent side, so we have to use our tangent function. Okay, and so let's set that up over here. Okay, if I wrote out tangent of x, that's going to equal 299.5 divided by 485, okay? Now, in order to find out what x is, I have to use an inverse trig function, okay? So I would switch my x and my ratio and write it as tangent inverse of 299.5 divided by 485, and that's going to equal x, okay? We could also say arctan. Okay, I could say arctan of 299.5 over 485, and that's going to equal x. Okay, so let's plug that into the calculator and see what we get. Okay, so here's that problem evaluated. Arctan 299.5 over 45 gives me 31.69. So if we round this, then I know that x is equal to 32 degrees. And that's my answer. Okay? And that's what that angle is. So there is a little bit of nuances here as far as like figuring out, what these different lengths are and stuff like that. Okay, let's move on to the next one. Okay, and this is the last one for the video. Okay, and it says use a diagram to complete steps to find the measure of the angle of depression from the top of the hoop to Lisa. And this is not to be confused with the same Lisa from Saved by the Bell. Okay, and I found this picture on the internet. Here's Lisa down here. Now, Lisa was one of the original cast members from the piloted season. Zach was on that season, so was Screech, and of course Mr. Belding. And that was the show supposed to be called Good Morning Miss Bliss. That's the one where they're in middle school. But Lisa's in that. Lisa's part of the original. Then they pick up Slater, and then they pick up Kelly and Jesse. But then you have this person over here, okay? And this person's name is Tori. Now, here's the weird part. In Saved by the Bell, you kind of have this problem, okay? It's not like South Park or like, The Simpsons where the people in the show don't age. all these people have aged, okay? So it got to a point where, where this original group actually graduated from high school, and then they start another season where these four, and Slater's in it too, where these four are in it. Kelly and Jesse aren't in it, but they pick up a new student, Tori, and so you have this group of students minus these two original members. And then you have the last season, which is season 5. Or maybe it's seasons, I'm not sure. But it's really, really weird. It's like, oh, no one's going to catch on. Okay, we've all graduated from high school, yet we're going to go to another year, exclude these two people, never talk about them again, but include this person, Tori. And I will say, the one-liners from that season are actually pretty good. Okay, all right, back to our problem here. Okay, so we have this diagram, complete the steps to find the measure of the angle of depression from the top of the hoop to Lisa. Okay, so here's what I know. Here's the top of the hoop, okay, which is 8.5 feet, all right? Just so you know, I'd be able to dunk on an 8.5-foot goal, but I digress. But what I want to do is we want to find the angle of depression, all right? So let me draw this horizontal line. We want to find this angle here, x, okay? Which is coincidentally the same angle as this angle of elevation, x, okay? So we can just use this triangle here. All right, now what I know is that this length here is 10 feet long, okay? This entire length is 8.5, but I want to know this distance here for this triangle, okay? Now Lisa is also 5 feet tall, okay? So, you know, how much higher, what's this length? If the whole thing is 8.5 and she's 5 feet, then what's this? So if I take 8.5 minus 5, that's going to give me a length of 3.5 feet. Okay, 3.5 feet. All right, so I know that this is my hypotenuse, okay, given this angle x here. Okay, this is my adjacent side, and this is my opposite side. Okay, so using what we know from SOHCAHTOA, I know that I'm going to use my tangent function, okay, because I'm given the opposite side and I'm given the adjacent side, which is 10, okay? So let's go ahead and set up our function here, okay, and I'm going to say tangent of x degrees is equal to 3.5 divided by 10. Okay, and so then what I have, in order to find x, I have to use the inverse function. Okay, I have to use tangent of 3.5 over 10 is equal to x, and this is tangent inverse, sorry. And so then I could also say arctan, okay, of 3.5 over 10 is also equal to x. Okay, so let's go ahead and plug that into the calculator and see what we get. All right, so then what we get is that arctan of 3.5 over 10 is equal to 19.29. So rounded to the nearest degree, which is what we'll use, we know that x is equal to 19 degrees. Okay, so this is where I think trig is really cool by utilizing the side lengths of a triangle to figure out angle measures, which I think is pretty cool. So I know this is a very long video. I know I went on a tangent with Lisa from Saved by the Bell, but I thought it was necessary. You guys are doing a really good job. These are some hard problems, but, you know, make sure you are writing everything down, setting everything up, and we'll go from there. See ya. Bye.